Okay, hey guys, this is the Module 7 test review. I'm going to go through all of the problems to make sure that you know what you're doing on the test. And so I would recommend going through this test review on your own and then coming back and seeing if you understand the problems and if you got the answers right. The key is also on the website if you want to check it. I also linked it to the assignment page in Canvas. So the first part of the test review is about angles. And I was going to have a more complicated test review and test for the angle part, but I decided to make it a lot simpler, just testing you on little things. Let me see if I have the other one on here. So I was going to have you do something like this, where you have to find all of the angles in a circle, and it's pretty cool. But I usually do it as a partner thing, and we can't really do that over Canvas, so I decided to do a multiple choice thing instead. So yeah, so that's why I don't know if you would have noticed, but I changed the test in the test review. So this one, we're going to start with the angles. So we have arc HDF, which goes all the way around like this. And we don't know what this angle is right here, but we know that this central angle is 60, so this is 60. This other one here is 90, so 60 and 90. And then we know that this is 85. We know this one is 60, this one's 90, this one's 60. So what we can do here, I'm going to put the calculator over here. We can just add these together and subtract it from 360. So I'm going to do 360 minus 90 minus 60 minus 85 minus 65. Or not 65, sorry, 60. So that gives us the answer is 65. But it's asking for the total arc. So we're going to do 60 plus 65 plus 90. So this arc is 215 degrees. Okay, the next one, we're looking for arc JFH. So J to F to H. And we don't know what these two are, but we do know that Fi is a diameter, because at the beginning it says assume that lines which appear to be diameters are actual diameters. So we know that's a diameter, which means the whole thing is 180. So if we do 180 minus 56, that gives us 124. So we know that this part is 124. And we need to add that to the 110 to get our answer. So that would be 234 for that arc. Okay. The next one is arc FB. It's right here. Actually, I'm going to do it in blue, just like the other ones. Maybe. Okay, arc FB. And then, so we know that this is 180. And then this is 50. So out here, this is 230, which means if we do 360 minus 230, that would give us 130 degrees for that arc. Okay, the next one is IJG, just like that. So once again, we know that this is a diameter. So this is 180. So we just need to add that to the 68. So that gives us that this arc is 210 and 48 degrees. Okay, so that's the central angle section. Then we have inscribed angles. So remember that we double the angle to get the arc, or half of the arc is equal to the angle. So whichever one it gives you, you just have to use that information to figure it out. So here, we're trying to find this angle. I'm going to call that X. We don't know what the arc is right now, but we could figure it out because there are 360 degrees in a circle. So I'm going to do 360 minus 125 minus 87. So that tells us that this is 148. And since we have the arc, we divide it in half, and that gives us the angle. So we have 148 divided by 2. Which gives us 74 degrees. So that's what that inscribed angle is. Our next one is the same situation. We need to find this arc. So we do 360 minus 95 minus 69. So that tells us that the arc is 196. And then we do 196 divided by 2. And that tells us that this is 98 degrees. Okay, the next one, we're trying to find this arc. That's our goal. So if we're given this angle, we need to multiply it by 2 to get the orange arc. So 72 times 2 gives us 144. And then we have 2 arcs. We need the third, or we need to subtract those 2 from 360 to be able to figure out that third arc. So I'm going to do 360 minus 144 minus 116. And that tells us that this arc is 100 degrees. The next one, this is a diameter. So that tells us that this angle is 180 degrees, which means that the arc measure is 180 degrees. So we just need to take 360 minus 110 minus 180. That tells us that this arc right here is 70 degrees. But it's asking us to find the inscribed angle for that arc. So we just divide that in half, which means that this angle is 35 degrees. And that's it for our inscribed angles section. The next one is interior and exterior angles. So when it's interior, we add the arcs together to divide by 2 to find that missing angle. If it's exterior, we subtract. So interior is adding, exterior is subtracting. So we're finding this one, I'm going to call it X. So we have 132 plus 50 divided by 2. So in the calculator, we have 132 plus 50, which is 182, and I'm going to divide that by 2. And that gives us 91 degrees for that interior angle. The next one is also an interior angle problem. So we're trying to find this arc. We're given that one, and we're given the angle. So I'm going to call this arc X. So we have X plus 60 divided by 2. And when we add the arcs together and divide by 2, that gives us the interior angle, which is 124. So what we do here is we multiply by 2. We have X plus 60 equals 124 times 2. That would be 248. Then we subtract 60. So we get X equals 188. And that's this arc over here. The next two problems are exterior angles because the angle that's formed is outside of the circle. So here we have to do our major, which is the bigger arc, minus the minor arc, divided by 2, and that gives us the angle. So this one is just like that last one where we have one of the arcs that we're trying to find. So the major one, we can see from the picture, that's 158, that's the bigger one. So we do the major minus the minor divided by 2, and that tells us that exterior angle, which we know is 42. So we do the same thing, we multiply both sides by 2. We get 158 minus x equals 84. And then here we can subtract 158 from both sides, so we get negative x equals negative 74. But since they're both negative, we can just say x is equal to 74. Okay. The next one, we're just trying to find the exterior angle here. So our angles, we have our major arc is 115, and then our minor arc is 55. So we have 115 minus 55 divided by 2. That tells us that this is 60 divided by 2, which is 30. So that angle, that exterior angle, is 30 degrees. So that's it for angles and arcs in a circle. Then you have arc length, which is next. So remember that the formula for arc length is whatever that degree measure is of the arc over 360. This tells us the portion of the circle that we're looking at. So the whole circle would be 360 degrees. If it's 180 degrees, that's half. So if we did 180 over 360, that's just telling us that we're looking at 1/2 of the circumference. So this part of the formula just tells us the portion of the circle that we're looking at. And since it's the arc length, we need to multiply it by the circumference. So if, for example, you were given a whole circle with a radius of, let's say, 2, and we needed to find the arc length, we would do 360 over 360 times 2 pi r. Well, in this case, r we said is 2. So the 360 over 360, that's just 1 because it's the whole circle. So the answer here would be 4 pi. And that's the circumference. So if we change this and we wanted this to be like half of the circle, let's say that this is our angle here, then we'd say 180 over 360 because now we just want half of the circle. Or if we just wanted 1/4 of the circle, like if the degree was 90, if we were just looking for that part, we would put 90 degrees like we have in number 13. So that's what we do for arc length. Okay, so like I said, our degree here is 90, so we do 90 over 360. That tells us that we're looking for, that's going to simplify to 1/4. So we're looking at 1/4 of the circumference. Circumference is 2 pi r, and r here is 13 miles. So the easiest way to type this into your calculator so that you get the answer that it will be on the test. Let me just check it really quick. I believe on the test I have it as multiple choice with pi in the answer, but let me check it. Sorry, I don't know if you guys can hear my dog moving around, but her collar is rattling and stuff. So yes, the answers on the test have pi in them. So if you just type all of this in the calculator, it's going to give you a decimal. But we need the answer to have pi in it. So on the calculator that I have over here on the side is the Desmos Scientific Calculator. You can access this on desmos.com, or you can download the app if you have a smart device like a tablet or a phone. It's super good. It's super good for doing fractions and whatnot. So we're going to do 90 over 360. It's the first part. And then we're going to do times 2, not 5, 2, times, we're going to leave out the pi. So I'm just going to type in 13. And this says 6.5, but I'm going to click this little fraction button over here and it's going to tell me it's 13 over 2. So we left out the pi in the calculator, but we're just going to write it in the numerator. So it's 13 pi halves. The units here are miles. And it's just miles because we're not multiplying, like, it's not an area, so it's not squared, and it's not a volume, so it's not cubed, it's just miles. The next one is 270 over 360 times 2 pi times 6. So I'm going to type this in the calculator. We do 270 over 360 times 2 times 6. And this tells us that it's 9. So our answer here is just 9 pi feet. The next one is also 270, so we do 270 over 360 times 2 pi times 13. So I'm just going to go back to the calculator and type in 13 instead of 6. This tells us that it's 19 over 19.5 or 39 halves. But remember, that's where the pi comes in because we didn't type it into the calculator because we just want pi as its irrational self here. We don't want a decimal approximation. This is the most exact form. And then the units here are kilometers. Our last arc length question is this one. So we have 90 over 360 times 2 pi r. So once again, we're doing 90 over 360 times 2, leaving out the pi, and then 11. I want that as a fraction, so we have 11 halves. But we need to include our pi here, so I'm going to put pi in the numerator. Our units here are meters. So this is what the answer would look like. The next section is super similar, but it's the area of a sector instead of the arc length. So the area of a sector is whatever that degree measure is over 360. And this time, instead of multiplying by the circumference, we're going to multiply by the area, which is pi r squared. So we have 270 over 360 times pi times 15 squared. So we're going to type this into the calculator just the way it is, except for the pi. So we have 270 over 360 times 15 squared. So that tells us that it is 675 over 4. We include our pi, and then we have kilometers squared because it's an area. So area is always squared. The next one is 255 over 360 times pi r squared. R here is 4. So I'm going to do 255 divided by 360 times 4 squared, which is 16. And if we look at the fraction here, that tells us that it's 34 thirds. Pi goes in the numerator because we didn't type it into the calculator, so we have to put it back in. This is feet squared. Then our next one, we have 45 over 360 times pi r squared. So we do 45 over 360. I'm not going to include the pi yet, but we have 15 squared. So then we have 225 over 8. We include the pi in the numerator, and this is feet squared. Our last one for area of a sector is 105 degrees. So we have 105 over 360 times pi r squared. So once you have this formula memorized, it's super easy to just type this all into the calculator and figure out what the answer is here. So on this one, it gives us 42 pi kilometers squared. And those are just like this would be like one of the multiple choice answers. They're not in decimal form. So the Desmos Scientific Calculator is super good for doing decimals to fractions. Okay. Now, the area of regular polygons, this requires a little bit more work. So I'm going to go through each of these. But from what I've seen on the homework, it seems like you guys are understanding it. I can see that you've done your work and stuff. So, yeah. So we're going to start with this one. So we want to break it up into smaller triangles as best as we can. That's not exactly in half, but that's okay. Doesn't have to be perfect. So if we're looking at this triangle right here, this is the one that's going to tell us, like, we know that this is going to turn out to be a special right triangle. So that's the one we're going to use, which means that this side is now 12. Because 24 is the whole length, but we're just looking at half. And then if we were looking all the way around this, this would be 360. But we have 12 of these, or sorry, 6, because we're breaking this triangle up into 6 triangles, which would be the same area as that blue one. So to find the degree measure here, we take 360 divided by 6, which tells us that this is 60 degrees. And this is 30, which is a special right triangle. So the one across from the 60, we know that that's smiley face, square root of 3. If we want to get the smiley face by itself, we divide by the square root of 3. So our smiley face here is going to be 12 square root of 3 over 3, or 4 square root of 3. You can also approximate this to a decimal. If you approximate it here and then you multiply it and then you multiply it, you will be bringing that rounding into each step. So your answer may be like a decimal place off. Like it might, if the answer says it's 0.8, yours might say 0.7 or 0.6. But whatever the closest answer is, if it's within like 1 unit, then it could just be a rounding error on the multiple choice. So just know that you could round it here, or you could leave it as 4 square root of 3. But if you round it here and then you round it again and then you round it again, like it'll bring that rounding error through the problem. But that's okay because it's multiple choice, so you should be able to select the correct answer. So we know that the height here, we just found that this is 4 square root of 3. So to find the area of the blue triangle, we do 1/2 times the base times the height. And I'm going to type that into my calculator. So we have 1/2 times 12 times 4 square root of 3. So the area of this blue triangle here is 41.57. Now we have the area of the big triangle is 6 times that, because we have 6 little triangles, little blue triangles in there. So I'm going to take this, I'm going to do 6 times 41.57. So the answer that you should see on the test is 249.42. So what I was saying is if you rounded it, you might get like 249.7 or 249.1, but that would be close enough to say, okay, that's probably just a rounding error. If it's like, if you get like 256 or something, that's too much. That's too big of a rounding error. But as long as it's like within 1 unit away, then it should be fine. Okay, the next one is also a triangle. So let's break this up into our small triangles. We just did this. We know that this is 60 degrees. This is 30. This makes it really easy because we know this is the short side. So this is like our smiley face. This is 2 smiley face, and this one is smiley face square root of 3. So we don't need the hypotenuse because it doesn't do us any good here. I'm going to color this one blue really quickly. I'm kind of a perfectionist, so it's a little outside the lines, but that's okay. So if the short side is 16, we know that this side is 16 square root of 3. So to find the area of this blue triangle, we do 1/2 times 16 times 16 square root of 3. So 1/2 times 16 times 16 square root of 3. The area of this little triangle is 221.7. And it's 702, so the 2 doesn't round up the 0 to a 1, so it's just 221.7. So the area of the big triangle is 6 times that, because we would have 6 little triangles in there. So we do 6 times 221.7. So this area is 1,330.2. Okay, now we get to go to a hexagon. So hexagons are also cool because they form special right triangles. They're just a little different. So in here, if we drew it like this, we'd have 2 small triangles for each side. There are 6 sides, so we would have 12 of these blue triangles in here. I'm just going to draw one to keep it simple. But we know that there are 12 of these, so we would do 360 divided by 12, which tells us that that little angle in here is 30 degrees, which means that this is 60. So it's also a special right triangle. And on this one, we have the medium side. So this is our smiley face square root of 3. So if we set these equal to each other, we just divide by the square root of 3 on both sides. And when we have a situation like this, where we have the square root of 6 divided by the square root of 3, we just do 6 divided by 3, which is 2. Because they're both radicals and the index is the same, so we can do that. So we would have 6 square root of 2 for this side over here. So now we're finding the area of this little triangle, which is 1/2 the base times the height. So I'm going to type this into the calculator. We have 1/2 times 6 square root of 2. And then right here, we don't want it to be 26, right? We have to arrow over so that it doesn't think that we want to type underneath the radical anymore. And then we do times 6 square root of 3. Or sorry, 6 square root of 6. So our answer here for this area of the blue triangle is 62.35. And then I'm going to roughly draw a hexagon here. This would be 12 times that area. So we have 12 times 62.35, that's 748.2. And we don't have units here, but if it was like feet, it would be feet squared. If it was centimeters, it would be centimeters squared. So whatever the units are, you just square it. And then our last one like this, I know this homework probably took you a little bit of time because it's kind of an intense process. But the point of doing homework is so that you can get quicker, so that when it comes to the test, you can do it quickly. So we just went over this. The small angle in here is 30 degrees because there are 12 of these triangles. So if we take 360 divided by 12, that's 30. So this angle is 30 and this one is 60. And then with the apothem here, it's really funny. The apothem, that means that that's a right angle. So we have a right triangle in here. It's a special right triangle. I'm going to cross this out and I'm going to put 7.5 here because it's just half of what we're looking at. This is the short side, so we need the medium side. So here, this is the small angle, so this is the short side. This is our smiley face. The medium side is smiley face square root of 3. The long side, or the hypotenuse, is 2 smiley face, but we don't need that because we don't use the hypotenuse here. If the smiley face is 7.5, that means that the medium side is 7.5 square root of 3. So, to find the area of this little triangle, this little blue triangle, we do 1/2 the base times the height. So in the calculator, we do 1/2 the base times the height. So on this one, we get 48.71. And then we want to find the area of this hexagon. So we do 12 times that because we have 12 of those little blue triangles. So we do 12 times 48.71. So the area of this hexagon is 584 times 52, or 0.52. Okay, the next section is on volume. So I went over all of the volume formulas, so it's good for you to memorize these, especially because you need them on the test. So I'm not going to review them a lot. I'll just write down what the formula is for each of the shapes that we're doing. So this is a cylindrical cone, right? The base is a circle and it's a cone. So the volume is 1/3 of the area of the base times the height. But we know that the base here is a circle, so the area is pi r squared h. And since it's a cone, it's 1/3. If it was a full cylinder, like if the sides went straight up, then it would just be pi r squared h. But since it's a cone, it comes to a point, it's 1/3. So now all we do is type in those values. So we have the volume equals 1/3 pi times 12 squared times 24. Because right here, this is giving us the diameter, but we cut that in half for the radius. So I'm going to type this in the calculator. So we have 1/3. I'm going to leave the pi out, and then I'll include it after. So we'll write down both answers. So we have times 12 squared times 24. So one way that we could write the volume is 1,152 pi centimeters cubed, or if we include the pi in there, then this would be 3,619.11 centimeters cubed. And I believe on your test, just like on the homework, it's in decimal places. So for the area of regular polygons and for the volume, it's decimals. So you just need to do this. Okay, the next one is 26. So on here, the volume, this is a sphere. So volume of a sphere is 4/3 pi r cubed. This gives us the diameter, but the radius would be 2. So the volume here is 4/3 pi 2 cubed. So we're going to do 4/3 and then 2 cubed, that's just 8. So we have that the volume is 32 pi thirds centimeters cubed, or the way that it'll be on the test is if we multiply it by pi. So this would be 33.51 centimeters cubed. Okay, the next one is a cylinder. So the sides go straight up, so it's just pi r squared, which is the base, and then we multiply it by the height. So now we can just plug in those values. So we have v equals pi times 11 squared times 12. So 11 squared times 12. That gives us 1452 pi miles cubed. Or if we multiply this by pi, we would have 4561.59 miles cubed for the answer. So this is the one that you'd see on the multiple choice. This next one is a little tricky because you have to find the volume of the base, or sorry, the area of the base, and then use that to find the volume. It's a pyramid. It's a hexagonal pyramid because the base is a hexagon. So we would still do the volume is 1/3 of the base, the area of the base times the height. So I'm going to sketch this hexagon down here. And we have the base and the height. So I'm just going to do the area of our blue triangle is this whole thing. We don't need to do half of it because normally we have to do half of it because that's what the special right triangle forms. But we know that the base is 7 because that's the side length, and then the height here is 6.1 because that's what this is showing us right here. This is like our blue triangle. And it's a regular hexagon, so all of these sides are 7. My 7s got worse as they went around. Okay, so the area of this blue triangle is 1/2 the base times the height. So we do 1/2 of the base times the height. So the area of the blue triangle is 21.35. And then the area of the hexagon is 6 times that because we would have 6 triangles of this area in here. So let's do 6 times 21.35. So that tells us that this is 128.1. This is the area of the base. So that goes right here. The height is 11 centimeters. So we have the volume is 1/3 of the base times the height. So let's do that. 1/3, not 1/2. 1/3 times the base, the area of the base times the height. So our volume here is 469.7 centimeters cubed. The next one, we also have to find the area of the base, but this time it's not a pyramid, it's just a prism. So we just find the area of the base times the height. The base here is a pentagon. I almost said hexagon. So in this case, we're given the apothem here, which is 5.5. And then the length of the base here is 8 kilometers, because all of these ones are 8. So basically what we're finding here, this part right here would be our blue triangle. And how many of those would we have? It's a pentagon, so we're going to have 5. So the area of our blue triangle here is 1/2 the base times the height. So we have 1/2 the base times the height. That gives us 22. And then the area of the pentagon is 5 times that. So that tells us that it's 110. And that would be kilometers squared because it's an area. Once we multiply it by the volume, or multiply it by the height, that tells us the volume, and that makes it a cubed volume. So we have volume equals 110 times 9. That tells us that it's 990, not 999, 990 kilometers cubed. Okay. Our last one is just a regular rectangular prism. So this one, you've probably learned that volume is the length times the width times the height. We could also look at it as the area of the base times the height. But either way, we're just multiplying 9 times 10 times 11. So that would be 9 times 10 times 11. That's 990. Whoops, 990. And this is meters cubed. And that's it for the volume. And then you'll have you'll have 6 questions on converting radians to degrees. So this is a degree. To go from degrees to radians, you multiply by pi over 180. To go from radians to degrees, you multiply by 180 over pi. So radians have a pi in them, degrees don't. So this degree doesn't have a pi in it, so we need to multiply by a pi, right? Because we want a pi in the radians. So the easiest way to do this is on the Desmos Scientific Calculator. We can put this into a fraction. We don't want the pi in there because then it'll give us a decimal. So we just want 120 over 180. That tells us that it's 2/3. So this is just 2 pi thirds in radians. The next one is 2 pi thirds. I wonder what the degrees are going to be. But the way we do this, since it's in radians, we want it in degrees, we need to divide out that pi. So that's a way that you can remember which one is which. So we don't want a pi with degrees, so we have to divide by pi. Then we do 2/3 times, not two halves, 2/3 times 180. That tells us that it is 120 degrees. Okay, the next one is -7 pi fourths. We don't want a pi in there because we want it in degrees. So the pi goes on the bottom. So the pi's cancel. So we're going to do -7 fourths times 180. That tells us that it is -315 degrees. The next one, we have -240. So we need a pi in there, so the pi goes on top. So we're going to do -240 divided by 180. Put that into a fraction, so we have -4 pi thirds. Then we have 340 times pi over 180, because we need a pi in there, going from degrees to radians. If I type that into the calculator, we have 340 divided by 180. This is 17 pi ninths. And then our last one here, we don't want a pi in it because we want it in degrees, so the pi goes in the denominator to cancel. So we do 7/12 times 180, which tells us that this is 105 degrees. Okay, and this whole test is multiple choice, so just make sure that you study. You should have homework assignments on all of this. You should have videos to watch, quizzes that you can take. Just make sure that you're prepared. I'm giving you 3 hours and 1 attempt on the test, so make it count. Good luck, guys.